Alright, so this is our presentation for the second topic, that is chemical processing calculations under materials. So let's zoom into it. Now, the agenda is a introduction, then we move to the topics, then the course description, course objectives, introductory concepts, material balances, and then we look at some reference tests. Now, course introduction. Chemical process calculations form the backbone of modern engineering, encompassing vital techniques that ensure efficiency, safety, and sustainability in industrial operations. From material and energy balances to reaction stoichiometry and unit operation design, these calculations are fundamental in transforming raw materials into valuable products. So this presentation explores the key principles and then applications of chemical processes calculations, illustrating their critical role in optimizing processes across various industries. It aims to equip students with problem-solving techniques and practical application experience for a variety of process-related problems, laying the foundation for further studies in chemical engineering. Now, let's look at the course objectives. By the end of the course, students will be able to now introductory concepts. One, understand engineering and chemical engineering. Two, convert between different engineering units. Three, compare dimensionless groups. Four, interconvert mass, volume, and moles and their flows. And then the last one under introductory concepts is to convert between different temperature scales. Now we have to understand the material balances too. So one, understand material balances and solution strategies. To perform material balances for systems with recycle, bypass, and then purge streams. Three, calculate the limiting reactant, excess reactants, fractional conversion, and fractional yield. And then the last one here is to perform material balances on combustion processes. Now, reference texts. These are some places that we've taken our texts from. You can look at them and then do further um, research on what we are going to present to you. Now, let's look at units and dimensions. First, we are going to look at the definition, and then secondly, we look at the quantities and then their units. This is so basic, right? But let's zoom into it. Now, definition of units, dimension, and then types. So we know that dimensions are basic concepts of measurements such as length, time, mass, temperature, and so on and so forth. So units are means of expressing the dimensions such as feet or centimeter for length, hours or seconds for time. So types of units. So we have there are several systems of units, but two primary systems that engineers use are the international system of units. So the French will call it International Système d'Units, and the American Engineering System of Units, that's the AES. Other systems are the centimeter, gram, second, and everything that you see here. Okay, so a system of units has the following components. One, base units for mass, length, time, temperature, electrical current, and light intensity. Two, multiple units, which are defined as multiples or fractions of base units such as minutes, hours, and milliseconds, all of which are defined in terms of the base units of a second. All right, so multiple units are defined for convenience rather than necessity. So it is more convenient to refer to 3 years than to 94,694. So the number you see, 94608,000 seconds. Pardon me. So three derived units obtained in one of two ways. The first one by multiplying and dividing base or multiple units. Okay. So what you see here, derived units of this type are referred to as compound units. So that's the first classification. And the second classification, so they are defined as equivalents of compound units. Okay, for example, the 1 ERG, and then which is equal to 1 gram centimeter per second squared. Okay, and then the second one there. Now, quantities, units, and symbols of the SI units. Now we have the quantity here, we have the units, that's the base unit, and then we have the symbol. Okay, so length is having the base unit as meter, and then its symbol as what? M, right? So we can have centimeter too, which will be cm. We can have mass, kilogram, and then the symbol is what? Kg. We can have grams, the symbol is what? Grams. Is G, sorry. Time, second, the symbol is capital X. Day, the symbol is still day. Temperature, Celsius and Kelvin, they have their corresponding symbols. And then ampere, yes. All right. Processes and process variables. Processes and process variables. A process is any operation or series of operations by which a particular objective is accomplished. In this course, we address those operations that cause a physical or chemical change in a substance or mixture of substances. The material that enters a process is referred to as the input or feed, and that which leaves is the output or the product. Okay, so it is common for process to consist of multiple steps, each of which is carried out in a process unit, and each process unit has associated with it a set of input and output process streams, right? So now let's come to the process unit. So a process unit is an apparatus or equipment in which one of the operations that constitutes a process is carried out, okay? Each process unit has associated with it a set of input and output process streams, which consists of materials that enter and leave the unit. All right. So now let's look at the process stream. The process stream so shows the flow of materials in and out of units, detailing quantity, composition, temperature, and pressure. Engineers use flow sheets to design processes and set conditions for reactors and heat exchangers. They manage production rates, solve problems, and adapt to market changes by understanding and measuring stream details. I like the flow sheets here. I like the flow sheets. All right, so my colleague is coming to continue.
Okay, so we are moving on to a different topic, that is material balance fundamentals. So our agenda for this topic is the introduction, the process classification, types of balances, the general equation, and the process unit. So we begin with the process classification. Chemical processes may be classified as batches, continuous or semi-batch, and as either steady state or transient. Before writing material balances for a process system, you must know into which of these categories the process falls. So we are coming to look into the classification of the process based on their variety with time. So the first one is steady state process. A steady state process is the one in which values of process variables do not change with time. Every time we take a snapshot, all the variables have the same values as the first snapshot, sorry. So it means that they don't change. And the second one, that's the B, is unsteady state process, known as a transient process. It's also the one in which the values of the process variables change with time. So every time we take a snapshot, many of the variables will be different from the first one. And I hope this is understandable. So we are moving on to the next. The ones that are classified based on how they are built to operate. So the first one is a continuous process. This is the one that has the feed streams and product streams moving chemicals into and out of the process of the time. At every instant, the process is fed and product is produced. Example are an oil refinery, a power grid, and a steady salary job. B, a batch process. This is classified based on where the feed streams are fed to the process to get it started. The feed material is then processed through various process steps, and the finished products are created during one or more of the steps. The process is fed and product results only at specific times. So it means that times are very important in process variables. Examples are making a batch of products like soap or a specialty chemical. So the third one is a semi-batch process, also known as semi-continuous. This is the process that has some characteristics continuous and batch processes. Some chemicals in the process are handled batch-wise. Some chemicals are processed continuously. So it means that it contains two processes, that is the continuous and the batch. So in other sense, you can make it in normal sense, you can even make it like a hybrid process consisting of the continuous process and the batch process, since they are all different processes coming together to make it one. So we are moving on to types of balances and general balance equations. So we have two types. We have the differential balance and we have the integral balance. So first we are going to handle the differential balance. This is the balance taken at a specific instant in time. It is generally applied to a continuous process. If the process is a steady state means that it doesn't change with time. And a differential balance applied to any time gives the same results. We will apply differential balances to steady state continuous processes. Each term in a differential balance represents a process stream and the mass flow rate of the chemicals in that stream. So let's move on to the next one, that is the integral balance. This is the balance taken at two specific instants in time. So it means that you have an initial time and you have a final time. It describes what has happened over the time period between the 2 points. An integral balance is generally applied to the beginning and the end of a batch process. It accounts for what happens to the batch of chemicals. We will apply integral balances to batch processes. Each term in an integral balance represents a process stream and the mass of the chemicals in that stream. So our next subtopic is process units, that is basic functions. So with the basic functions, we have the divider into brackets splitter. A splitter is used to divide the flow rate in a certain stream into two or more streams with different flow rates. In the schematic diagram, the diagram here shows how the divider is like and how it functions. So it says that in this case, the composition of the streams, that is F1 and F2 and F3. So you see F1 there's one there, F2 there's two there, and F3 there's three there. It's the same since there's no operation taking place between the inlet and the exit stream. So the inlet can be the feed, where the feed is the F1, and the exit streams can be F2 and F3. There's only one independent material balance, even in the case of a multi-component system, since all the components are equal. But one thing we have to take note is that the mass flow rates of F1, F2, and F3 may be different. So I'm going to hand over to my colleague to continue from there.
So I'm here to continue from where my colleague ended. So we have the filter. So if we say filter, the first thing that comes in mind is filtration. So now filtration is a technique used either to remove impurities from a liquid or to isolate a solid from a fluid. Filtration is commonly used a mechanical or a physical operation that is used for the separation of solids from liquids by interposing a medium through which only one fluid can pass across a section. So yeah, this is just like an overview of everything. Let's wrap up. Then multi-effect evaporator. So this is a schematic diagram of a three-effect evaporator. It's a three-effect evaporator because it has three sections, as you can see, and it is used in various chemical or food processing. Yeah. Then we have the humidifier. The humidifier is a device that increases the amount of moisture in other air or a stream of air. It operates by allowing water to evaporate from a pan or wetted surface or by circulating air through an air washer compartment that contains moisture air. Then we have the dehumidification, which is a dehumidifier with an internal cooling or heating coils. So these are all examples of devices. And you have leaching and extraction. So leaching is as you know from basis, leaching is the removal of material from solids by dissolving them. So chemical process industries use leaching, but the process is usually called extraction. That is the leaching that is the leaching of toxic materials into groundwater. It's a major health concern. So thank you very much. And this is the end of my presentation by Group 1. Thank you.